This is Algebra 2 with Trig. This is section 4.5. We're looking at learning about radicals and how to rationalize the denominator. We're going to look at perfect squares. There's several perfect squares, of course. 1 squared, 2 squared, and 3 squared. 4 squared is 16. 5 squared is 25. 6 squared. 7 squared, 8 squared, 9, 10, 11, 12. Those are definitely the ones you should be able to recognize and run with right away. 13, 14, and of course 15 to 25. Those are other numbers that will come up consistently throughout this course. A number r is a square root of a number s if r squared equals s. So r is a square root if you have to square it just to get to the number. So if we take our square root of s would be considered a radical. This symbol, which you often call a square root, we're going to call it a radical sign. It's a very broad term that can be represented with square roots, with cube roots, even with the fourth or fifth roots. The number s beneath the radical sign is called the radicand. So we're going to look at some properties that deal with radicals. If you have a value underneath your radical, and it can be broken down into two factors, like a times b, then you could break that apart into the square root of a times the square root of b. More importantly, if it's broken apart, you can combine them together. So with the square root of 18, you could work with any two factors that make 18. For a good practice is trying to use our perfect square from our list we made up here. So which of these numbers goes into 18? 2 is not an option. 6 is not an option. But 9 is. 9 does go into 18. It goes in there 2 times. So you could break this down into the square root of 9 times the square root of 2. The square root of 9 is 3, so it's 3 square root 2. You would get the same thing if you used 6 times 3. If you use 6 times 3, you would have to break that down again to say 2 times 3 times 3. That's 6 times 3. Now you can see that the 3 and the 3 make a 9. You're doing square roots, so you're looking for two numbers being repeated. The 3's are being repeated. I like to circle those. And that becomes 3 square root 2. So you're going to get the same answer either way that you do it. It's clearly best to use the perfect square that can break down most cleanly. With a quotient, if you have a over b and you're taking the square root of the whole value, we can break that apart into the square root of a over the square root of b. More importantly, you can put it back into a full radical if you would like to reduce that. So we look here, and we have the square root of 2 over the square root of 25. And we're going to find out that it's not proper to leave the denominator with a square root. So we're going to say the square root of 2, because I can't break that down at all. But the square root of 25 does become 5. When we're simplifying these roots, square roots, a square root expression is fully simplified if the following conditions are true: that we have no perfect square factors other than 1, because of course 1 is always in there, and that can't be inside the radicand, and no radicals, listen to this one, no radicals can appear in the denominator of a fraction. So let's see how to simplify the square root of 75. Well, think about what numbers multiply to be 75, and that's 25 times 3. 25 can be broken down into 5 with the 3 left still inside. So we know the square root of 25 is 5, and then we have the 3 that is still inside. So to simplify the square root of 75, that's 5 root 3. Let's say you saw something else. Let's say you saw 15 times 5. That's okay, that makes 75. But you don't have a perfect square in there. So we say that 15 is 3 times 5 times the other 5 to make 15 times 5. Now, do you have two of the same number? Yes, we do. That's kind of your 25, if you want to call it that. And the square root of that would be 5. Square root 3. So either way you do it, you get the same result. In this case, we have the square root of 7 times the square root. What makes 35? 5 times 7. So we could put this all underneath the same one. It's real convenient when they're next to each other, but it doesn't matter. You have two of the same term, so I know that my reduced radical is going to be 7 square root 5. You're welcome to multiply the 7 and the 35 together and then go break it down. It'll be broken down by 35 and 7, or 49 times 5, and you'll get 7 root 5. No need to make the numbers bigger. Here we have a square root over a fraction. So I'm going to take the square root of the top, square root of the bottom. Square root of 100 is 10. Square root of 169 we talked about was 13. So that's our final answer. We have a square root over a fraction. So we're going to say square root of 11 over the square root of 144. I don't know the square root of 11, but I do know the square root of 144. And that's a good thing, because remember, we're not supposed to leave a square root in the denominator. On the second page, we're going to talk about rationalizing the denominator. The process of eliminating a radical from an expression's denominator, that's what rationalizing the denominator is. It's eliminating the radical. This table shows how to eliminate it. This will go by real quick. We'll practice it when we're down here. But if your denominator is just the square root of a number, by multiplying by the square root of that number, the square root times the square root crosses the square roots off, and you get what's inside. Now that's different if you have a binomial. If you have a number plus the square root of a number, the only way to get it to cross off, if you tried the square root of b, They would cross off with the square root of b, but it would be multiplied on to the a. If you did what it was exactly there, a plus the square root of b, you would get this middle term. So the only way to make it be eliminated is to multiply by what's called the conjugate. Let's try that. A plus the square root of b and a minus the square root of b. Watch what happens even when we use variables. A times a is a squared. A times negative square root of b is negative a square root b. Positive square root of b times a is a positive a root b. And then positive square root b times negative square root b gives us negative square root b squared, because b times b is b squared. So we have a squared. Our middle terms cross out completely, minus b squared. And I'm going to take the b squared out of there. When you take the square root of b squared, you get b. And the same idea would be a, change the sign, square root b. The expressions when we're working with a square root b, or when we're working with a minus square root b, they're called conjugates. They're conjugates of each other. The product is always a rational number. It would be a squared minus b will be what that product will be. Let's try it. So we have a fraction. We're taking the square root. We're going to say the square root of 2 over the square root of 15. With this example, we don't know what the square root of 15 is. So we're going to use our b example here. We just have a square root down there. So we're going to multiply. You did this sum in geometry class. When you multiply the square root of 15 times the square root of 15, you get the square root of 225, and that can always be reduced. It reduces always, if these are the same numbers, it reduces into those numbers. Square root of 30 cannot be broken down. With the next example, we notice that the denominator has two pieces to it. It's called a binomial. One of those has a square root in it. So we're going to multiply by what's called the conjugate. So you use the same numbers, the 5 and the 2. You put the 2 inside the square root, just like it is, but you have to switch the sign. You have to do that to the top and the bottom because you're multiplying by a value of 1. Now, when you distribute through, we're going to get 4 times 5, which is 20. 4 times square root of 2, which is 4 square root 2. You don't say 4 times 2 is 8. You say 4 times the square root of 2. Here, 5 times 5 is 25. 5 times the square root of 2. Negative square root of 2 times 5. Negative times a positive is a negative. Root 2 times root 2 is 2. The 5 root 2's cross out, and you're left with 20 plus 4 root 2 over 25 minus 2, which is 23. That cannot be simplified anymore. Here we have a square root over a fraction, so we break it down into the two pieces. And we know the square root of 9, which is 3. 8 can be broken down into 4 times 2. So when you pull the square root of 4 out of there, which is 2, you're left with 2 root 2. Now we have 2 root 2 in the denominator. The 2 is your radical. We could have done this originally up here and worked with square root of 8, but you can also simplify it, so you don't have to simplify it later. And now you only have to work with the root 2. So the top becomes 3 root 2, and the denominator becomes 2 times the square root of 4, which is 2 times 2, which is 4. For part D, we're going to multiply by the conjugate. In parentheses, not in parentheses, it doesn't matter. You're going to distribute through. Seven times 7 is 49. A positive 7 root 5. A negative 7 root 5. And a negative 5. Because 5 times square root of 5 times square root of 5 is the value of 5. So we have negative 42 minus 6 root 5. Here, what's the middle terms cross out completely, and we're left with 44. Now you might notice that there's a common number that can be reduced out of all of those. So 2 can come out of each of these 3 numbers. We don't care about what's inside the square root. So we get negative 21 minus 3 square root 5 over 22. That's your best answer. This last example here, it's bigger than the rest. Remember, we got to multiply by the conjugate, which is the opposite term. So if this is 2 plus the square root of 10, I have to multiply by 2 minus the square root of 10. I'm going to do that to the top and the bottom. I have to multiply by a value of 1. So don't multiply by 3 minus square root 7, because we don't care about the top. The top can be any numbers it wants to be. So we have to multiply by a value of 1. So we're multiplying by 2 minus root 10, 2 minus root 10. So in hopes that the radicals will be away from the denominator. So here we got to FOIL it all up. 3 times 3 is 6, minus 3 root 10, plus 2 square root 7, minus the 7 and the 10 make 70. 2 and 2 make 4, minus 2 root 10. The insides make a positive 2 root 10, minus the square root of 100, which is 10. The top cannot be reduced at all. Those terms are completely separate. It's kind of like having a 3x and a 2y. You can't combine those together. These terms cross out, and you have 4 minus 6, so you get a negative 6 in the denominator. It's just fine for you to come back and change all the signs on top and make that denominator positive. I won't make a big press about that, but in terms of a proper form, sometimes people believe that the denominator can't be a negative. That's not part of our lesson that we're doing here today. but just to let you know what others may expect. Now we're going to talk about solving. Solving brings in a whole new dimension here. Of course, we're going to solve like we would any equation. 80 divided by 5 is 16. When you take the square root of both sides, this is where we get the idea that we get plus or minus 4. Because when you're taking the square root of both sides of an equal sign, the plus or minus has to be incorporated there, because your x value could be a positive 4 to make 16, or it could be a negative 4 times negative 4 to equal 16. We're going to solve our equation just like we would with any type. We're going to collect our like terms. 2x squared equals 50. Divide by the 2. X squared equals 25. When you take the square root of both sides, you get plus or minus 5. When you have a fraction, you always multiply by the denominator. A lot of people talk about multiplying by the reciprocal. It's the same thing. Just make it a little cleaner by saying the denominator. If the numerator was something different than 1, then I would say divide by that after you multiply by the denominator. X minus 6, quantity squared, equals 32. When you take the square root of both sides, you no longer have the square on this side, but you do have to say the square root of 32 on that side. And when you say the square root of 32, that is 16 times 2. So we're going to say x minus 6 equals plus or minus 4 root 2. Then, of course, x is not all by itself yet. So I'm going to add the 6 to the other side. And now I have my solution. Notice where the plus or minus goes. It doesn't go in front of the 6. You cannot combine the 6 with the 4. It's 6 plus or minus 4 root 2. Add the 6 to the other side. Get the value of 4. You have a denominator, so multiply both sides by a denominator. So we get x squared equals 100. Take the square root of both sides. So x is positive 10 or x is negative 10. Notice if you plug in negative 10 here, you get negative 10 squared, which is negative 10 times negative 10, which is 100. 25 goes into 100 4 times. 4 minus 6 is negative 2. It's a great way to check your work to be sure what you're doing is accurate. Okay, next, we're going to be dropping an item. This is just dropping it straight down. You're not throwing it, shooting it, kicking it. You're just dropping the item. Just dropping it. We're going to get h of t, which is the height in terms of time, negative 16t squared, minus your original height. So we call that h of o. So, if you drop an object off of a roof of an apartment building, the apartment building is 240 feet tall. How long will it take it to hit the ground? So let's get a bit of a drawing going. So there's our building. We have you hanging over the edge, ready to drop a water balloon on Susie, bad Kelvin. And so how long will it take for that to occur? What is your height in terms of time? Negative 16 t squared, t is your time, plus, that should be a plus. I think up in our notes here we said minus, but that should be a plus. Plus h of o. So h of t in this case is going to be negative 16t squared plus 240. 240 because the building is 240 feet high. Now, what is the height? Well, we want to know when is it going to reach the ground. The ground means a height of 0. So if you have a height of 0, now we got to solve this problem. In the past, we've been able to factor. This one may not factor very well. Recently, we have learned about solving, and we can solve using square roots. Notice this does not have a b value. There's no b value involved. So we can just subtract the 240. We're going to divide by our negative 16. Okay, and we get the answer of 15. 15 is not our answer, though. Not the final solution. Now we've got to take the square root of both sides. So the square root of 15 equals the square root of t squared. Plus or minus the square root of 15 equals t. So time isn't going to be negative. So time is going to be the square root of 15, which is approximately 3.87 seconds. So it's going to take almost 4 seconds for an item to fall off the top of this apartment if the apartments are 240 feet high. The equation h equals 0.019 s squared gives us the height of the largest ocean wave when the wind speed is s knots. What is the wind speed for a 20-foot wave? Well, we're dealing with h of s. We know what the equation is, 0.019 s squared. Now it's telling us, let's read that again, this equation gives us the height of the largest ocean wave. So if our wave is 20 feet, we can solve to figure out what s is. And we do that by dividing by 0.019. When you divide by a number that's smaller than 1, it's going to give you an answer that's larger. And then when you take the square root of this number, s is going to be plus or minus the square root of 1052.6. It's not a 5, that's an s. So our s is going to be plus or minus 32.44. Speed's not going to be negative. So a 20-foot wave comes from 32.44 knots. So the more wind there is out on the ocean, the bigger the waves automatically become. And you're able to calculate the expected waves by whatever the speed of the wind is. A water balloon is dropped from a 59-foot window. How long does it take for the water balloon to hit the sidewalk? Here is our equation that we're using. So we're using h of t equals negative 16t squared plus h of o. Well, we want to know when it hits the sidewalk, so it's 0. We're working with a 59 from a 59-foot window. So to solve this, we're going to subtract the 59. Divide by the negative 16. So t squared is going to equal 3.68. And when you take the square root of that, that is going to be the square root of 3.68. Which our t value is going to be approximately, we don't want negative time, so we're only going to look at the positive time, 1.92 seconds. So maybe Kelvin will get a splash on Susie a little bit quicker this time if he goes from 59 feet instead of 240.